start now.
Okay. Hi, Rashmin, are you there?
Yes,
So, welcome everybody. And as Rashmin will take us through the program and introduce the students to describe the other projects, I would request students also to be ready, whomsoever is interested to explain their project in a quick walkthrough. Rashmin, please start.
okay, so good morning everybody. So we are today showcasing the work done by our students of the Building Energy Performance Program in their first and second, third semesters. So Building Energy Performance Program is a program which talks about energy efficiency of buildings, and energy efficiency of buildings is a national imperative as building energy consumption is on rise in India. And in this course, in this program, students learn about the interaction of the building envelope with the interior and exterior environment. So this is covered in the first semester in the PC Comfort Lab. And so I will take you through the PC Comfort Lab portfolio. So can we just open one of? So this is the daylighting part. So you can just, yes. So, okay. So in the PC Comfort Lab, this is in the first semester, students learn about the interaction of the building envelope with the interior and exterior environments. You can see that we cover shading analysis. So this is the first exercise that the student has put up. How can you just scroll down?
Organized. Third thing you will notice is too much.
So please, if you could just scroll down a bit. So this is the shading exercise. So the major exercise in this PC Comfort Lab is a solar cooker exercise. This is an exercise with which the students learn about the heat gains and losses. So here we compare, or we try to draw an analogy between a solar cooker and the building. So it's just like a building with an envelope and a fenestration system which is at the top. So the students, what they do is they design, fabricate, and experiment with the solar cooker, and in this way they learn how a building interacts with the exterior environment and how to minimize the heat gains and how to increase heat losses. So this is the process that the students have carried out. They take care of the location, global location, and they learn about different materials. As you can see here, they try to incorporate different materials so as to control the U value of the building envelope. And then if you could just go down, they also test the solar cooker. They also numerically model the solar cooker. So on one side they are testing the solar cooker, and on the other they are simulating it so as to compare the numerical results with the experimental results. And here you can see that the cooker is reaching the desired temperatures, and if you could just scroll up, you can see that they were also able to cook some of the things. They also do climate analysis as it was. So here, yes, so this, you're scrolling very fast. So they also do some measurements with the hobo loggers to measurement of the environmental parameters like temperature and relative humidity. So this is what you're seeing currently. So then they install the hobo loggers, which measures temperature, RH, and lux levels, and they see what's happening in the room. And they try to derive conclusions out of it. So this was one of those exercises, and they try different combinations: window closed, window open. And then this is about the psychrometry. So we try to teach them about air and moist air. So this is done with the help of a psychrometric chart. So they learn about how moist air is impacting their thermal comfort and the load that comes on the air conditioner. So we try to teach them the psychrometric chart. So please go down.
It's just બે દિવસથી બહુ જ હેક્ટિક છે અને પછી તો
So, and finally they also, so in this course we have 3 modules. First is the building physics concepts, the second is the experimentation, and this is the third module, which is building energy simulation.
લેટ થાય છે તને
So they model the building
already સવા ગયા
at the envelope level and try to optimize it. And so here you can see that they have quantified the cooling loads and the solar gains of a building by performing an annual simulation. So This is again more results of the cases that they have carried out, the envelope optimization that they have carried out. They have checking the position of the insulation, whether it should be inside or outside, and what's the effect of that. So this is all about that. Yes, please go down. Okay, so they also see the effect of orientation. So basically, by modeling a building, they come to know what are the gains and how different parameters like the orientation, building characteristics are going to affect the energy consumption, and how that can be brought down, which is basically the intention of the program, that is to reduce the energy intensity of buildings so that they reduce their environmental impact. So that's more or less about the PC Comfort Lab of the first semester. And then I would request the Hate now to go through the Ideal Lab, which is from the third semester, where they learn about lighting and daylighting, and WBD, that is whole building simulation. So I would now request Hate to go through his portfolio on Ideal and WBD work.
Hate, are you ready?
Yes, ma'am, I'm ready.
Okay. Hemant, can you assist? Okay. Hemant, you are on mute.
Hey, so you will do or I will do for you?
Sir, I'll talk about my portfolio.
No, but do you want Hemant to share the screen, or are you going to do the?
Yes, yes.
Okay. Hemant, can you assist?
Okay, yeah.
Thank you.
Uh, yeah. Oh, yes, this one only. So I'll start now. So this lab was a lighting and integrated design lab. So in this, the lab was divided in two parts. In the first part, we learned the aspects of daylight and artificial lighting. And in the integrated design lab, we combined our approach from, like, we combined our learning from the previous 3 semester and applied it on a whole building design and to optimize its energy performance. So first we'll go through the lighting part. So in the lighting part, we learned various metrics like daylight factor, special daylight and autonomy, and annual sunlight exposure. So first was can you go down? So first exercise was to measure the daylight factor in 2 rooms and compare how illuminance levels varied with distance from window, as well as we saw the uh, additive nature of lighting in this exercise. Also, we compared the daylight factor on a work desk over a particular day. So this exercise was just to understand the metrics of daylight factor of assessing daylight performance of a room. Now, can you go down, please? Uh, yes, so in the second exercise, we learned to electric lighting design using a DIALux Evo software. So in this, we were given an exercise to reconstruct a GIDC Bhavan of SAP and convert it into. So for my case, it was I needed to convert it in a conference room design, and the electric lighting design was needed to be considered following the UFC guideline, in which we need to measure a particular lux level at a work trend level according to that guideline. So we, in this exercise, we learned the distribution of light, and as well as we learned the parameters like unified glare ratio, and we understood that what are the importance of lux levels at work plane on horizontal and vertical level. And so as you can see from the pictures images on the right side, that we gave 2 alternatives of lighting design for the conference room, and both were meeting the criteria of UFC guideline. So that is what we learned. Can you go down? Yes, and this also we conducted a mirror box experiment. So as the university was locked down, so we tutor helped in conducting this experiment. So in this experiment, what we learned basically is, through a physically scaled model, we see the variation in daylight performance of a building by changing some particular parameters like window to wall ratio, the shading device, also the window roof to skylight ratio were the parameters that were assessed. So a physically scaled model was prepared, and it was checked. It was the performance of which was analyzed in a mirror box, which is at the CARB facility of SEPT. And in for my case, we assess the performance of different light shelf using this mirror box experiment, and the illuminance level inside the model were assessed, and performance of different light shelf uh, were analyzed using this mirror box experiment. Can you go down? Uh, yeah. So the next part of this semester was the integrated design lab. So in which we were given a whole building design. So for which we were given a hospital building in Ahmedabad. So for that we needed to improve the energy performance of this building. So what we did was, first we selected two ground and first floor of the building, and basic information is given in this slide. Can you go down? So first, how our approach was to first we make this building as a ECBC compliant. So we get exposure of how to make a building a code compliant. So we made it ECBC compliant, which is basically an energy conservation code for commercial buildings in India. So that we using that whole building performance method, first we made our building ECBC compliant, and after performing climate analysis and incorporating passive and active strategies, we further increased the energy performance of this building. So this is typical climate analysis was done, and different passive strategies were identified from this climate analysis. Also, cooling degree days were also identified, and passive strategies like evaporative cooling, night purging, as well as geothermal heat source and radiant cooling were identified. Uh, can you scroll down? Yes, also the daylight compliance of the building were assessed. So for a given hospital building, UDI matrix was assessed, and no architectural changes were made, only by changing the reflectance and providing shading device according to the shading mask for the Ahmedabad. Daylight compliance for hospital building was achieved according to ECBC guideline. Can you scroll down? So this is basically a design of radiant cooling system. So as Ahmedabad was hot and dry climate, so latent load was not that high. So radiant cooling system was designed. So uh, for the radiant cooling system, two separate chillers were provided. One was serving radiant ceiling, and one dedicated outdoor air system was provided to take care of the latent load. And through this radiant system, we were able. Can you scroll down? So through this radiant cooling system, we were able to achieve the similar comfort level as per conventional system with higher air temperature. And because of this, can you scroll down, please? So because of this radiant cooling system, we were able to reduce our energy performance index, which is in kilowatt hour per meter square per year. From BAU case, we were able to reduce the EUI from 247 to 131 for radiant cooling system. Also, a night ventilation, radiant cooling with natural ventilation was also incorporated. So with combined effect of radiant cooling and natural ventilation, the energy performance index of 121 was achieved. So we could make our building even super ECBC compliant using these strategies. So can you scroll down? Also, to understand the economic aspects of energy conservation measures and to check the viability of each individual energy conservation measure, a life cycle cost analysis was also carried out to see the return on investment, and also the simple payback period was calculated. So from and in life cycle cost analysis, net present value was considered to So from this LCCA, it was found that the for uh, from BAU to ECBC compliant has a return on investment of around 15%, and radiant cooling had return on investment around 27%. So that was understood from this economic aspect of energy conservation measure. Thank you.
Great. Thank you, Hate, for explaining your project. It's a really definitely interesting one. Rashmin, or would you request, or would you have any other students in mind? Do we have other students on board who would like to explain a few of their projects for us? Our audience, I'm sure, would definitely want to know more.
I think we could have one more presentation from the PC Comfort Lab. Does anybody want? Because Heath presented the ideal
Right.
work, so maybe somebody from the first year could pitch in.
Rashmin, would you like to choose a particular student and ask them to do the needful? Or do we have any student who would like to participate voluntary for it?
I'm not able to see who is. I think Sachin has raised his hand, so maybe we can ask Sachin to present his work.
Yes, Sachin,
Yeah,
can you hear us?
I
Great.
will present.
Okay, you want to present? Could you, do you want to share the screen or you want Hemant to assist you?
I think I will share my screen.
You
That
share your
will be-
screen? Okay, so Hemant would just stop sharing his screen then. Hemant, thank you. Sachin, you can share your screen, please.
Is my screen visible to all?
Yes, yes, it is.
So, yeah, so this is what we all did in our semester one for passive comfort lab. In this, initially, various passive design strategies were studied with the analyzation and implication of weather data through tools like climate consultant, DView, and we also looked at how the implication of that analyzed data from these tools can be implied on the buildings. And then we later on did some exercises on the heat transfer principle, both numerically, and then we later on did the practical aspects with the help of solar cooker and tried to do the parallel analogy between the buildings and the solar cooker and how it deals with it. And later on we moved to the building simulation. In that particularly, we with the help of simulation and modeling through design builder, we looked at how we can optimize the our building envelope and various aspects of it. So starting with the first one, in this we have the evaluation of weather station site. So in this, our main aim was to locate a specific point for a weather station around the 10-kilometer radius of our nearby house, as this is done totally online. And we also have to make a difference between the official weather station and the weather station that uh, we are proposing in our nearby location. So here we looked at how the urban scape, or in this case particularly we looked at how the urban fabric, the surface layer, and also about the urban canopy layer, which is mostly take place. So the key learning was like how the each device, whether it is used for the measurement of temperature, rainfall, and other things, how they are placed at a particular place, and what are the various conditions that we have to taken into consideration while putting them in. And and also we looked at various scales like local scales, micro scales, and mega scales, and how it deals with it. So moving it to the next, yeah, this one is the that we did with the tools like climate consultant and DView, and we looked at the graphical data of various locations, and with the and by analyzing all these these data of the location, whether it is temperature, the sky cover, rainfall, or the windrows diagram, we came up with the implications of it, that how we can take this forward uh, and take all these environmental condition into the advantage of the building by the various passive strategies. Yeah, this particular exercise we did practically in our home with the hobo logger, which which measures the temperature, RH, and the lux level. So in this particular exercise, we selected the space for it, and we located our hobo logger with a specific consideration, like what is the activity, and what are the aspect we want to analyze with this. And with this uh, we did this for various conditions, like first of all we kept the door closed for 2 days, then open, and then by putting some insulation over the windows and doors, and then we generated the data through it uh, by with the help of software, Hobologer software, and we analyzed that how it will affect the temperature. Like we can see there is a thermal lag, and how the heat is getting stored when the doors are closed, and various other things. This is the same thing, but in this case we move to the other space of the house, and these are the numericals that we did over the heat transfer principles, which 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 gives us insights about that how the surface area, how the U value, and how the air change through the room affect the overall temperature inside, and how the inside temperature and the outside temperature of the building envelope uh, matters. And later on we put this into the practicality aspects, and we did this our solar project exercise. In this we first we documented and analyzed the Tulsi solar cooker, which we took as an example, and then we moved by taking the learnings from Tulsi solar cooker. We designed our own prototype, and then numerically made a tool on Excel that how our solar cooker will be performing. And then later on we constructed and experimented and looked at how it performed, and what are the various components that we have to take into consideration while doing all this.
Sachin, you have another 5 minutes to wrap up.
Yeah, yeah, sure.
Thank you.
So this is the various assemblies that we created for the glass assembly, and we looked at the materials with various U values of it, that how it impacts the heat in and heat loss. And this is how we drawn the analogy between the solar cooker components and the building. Like glass, we take the window wall ratio, joinery details, envelope, and the air tightness through gasket, and the black matte paint, how the SRI works with all paints and all. And later on we move to this building simulation part. In this we we make the hypothesis that what will gonna happen when we orientation, when we are making changes on the orientation, window wall ratios, and other aspects of the building envelope, and then analyzing it through the simulation by design builder, and obtaining the graphical data, and putting the results in, and also looking at how the cooling load of the building inside is getting reduced by various components. Yeah, that's pretty much about it.
Thank you, Sachin, for an insightful insight into your project. I really want to thank all the participants and Rashmin for being present here and coordinating the entire presentation. Rashmin, would you like to say something regarding the programs? Anything more would you like to highlight?
I think more or less I think students have done a good work in their studios, and this is the main objective of this program, is to give hands-on learning, so that it's not only about the theory modules, it's about measurement and experimentation and building simulation as well. So we try to give a hang of the reality to the students, so that when they go outside in the field, they are well prepared for it. So
Great. Thank you so much, Rashmin. Thank you, students. And please do share the link across all your fellow students, professors, or other, people you feel it's time to, let the world know what kind of projects are being done at CEPT and what kind of projects or work is being done by you, the kind of hard work that you all put in. All right. See ya. Thank you so much.
okay, thank you very much. Bye.
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 Bye.